2025. Imagine a world where the most powerful machines on Earth, the very engines of our future, are built without a single tool from the West. For decades, the United States has held an iron grip on the most advanced semiconductor manufacturing, a bottleneck for every nation, every company, every military. But what if that chokehold is about to shatter? What if an Eastern superpower, locked out of this elite club, has just engineered an impossible breakthrough? What if they've already found a way to create the next generation of chips, the SMIC 1nm chip in total isolation? The real story isn't about trade wars or tariffs. It's about a silent, relentless technological race, and the frightening possibility that one side has already crossed the finish line. The biggest secret in technology isn't what's being built in Silicon Valley, but what's being developed in silence, behind closed doors, without the world's most advanced equipment. Welcome everyone to Revo Now, where we decode tomorrow's hidden tech landscape. Today. And I promise you this, by the end of this video, your entire perspective on global power, on technology, and on the future itself will be fundamentally and perhaps terrifyingly altered. At Revo Now, our mission is simple. We look past the headlines and into the silent revolutions shaping our future. We believe that understanding these shifts isn't just about curiosity, it's about survival. Because the technology we're talking about today, the technology that powers everything from AI and robotics to quantum computing, is about to enter a new, far more dangerous era. The future of tech jobs, global finance, and even your personal security could hinge on what happens in the next 12 months. So stick around, because the details of this SMIC breakthrough could be the single most important piece of information you learn all year. For years, the global tech industry has operated on a simple, undeniable truth. You can't build the most advanced microchips, the 7nm, 5nm, or even 3nm nodes, without equipment from companies like ASML in the Netherlands, or Applied Materials in the US. This is the public knowledge layer. We've all seen the news reports and the headlines about sanctions and export controls. The US has used this dependency as a strategic lever, tightening the noose on China's access to cutting-edge tools. Every major news outlet has covered this. They've shown charts of the global supply chain, highlighting the bottleneck. Everyone knows that China's biggest chip maker, SMIC, is stuck. They can't get the EUV lithography machines. They can't get the crucial components. The narrative is that without these US tools, they are forever relegated to second-tier status. This story is everywhere, from the Wall Street Journal to CNBC. They report on the latest sanctions, the newest restrictions. We're told that this is a technological dead end for the East. We are led to believe that the future of artificial intelligence revolution and quantum computing will be an exclusively Western one. The narrative is comforting, and it makes sense. It's logical. But what you're not hearing is that this very logic is based on a flawed assumption, an assumption that is about to be shattered. While the world was focused on the public trade wars, a silent war was being waged in the shadows. We've uncovered evidence of what can only be described as an end run around the established technological order. Instead of trying to replicate the West's complex and expensive EUV machines, SMIC and their partners have been exploring entirely different, highly unconventional methods. We're talking about obscure labs that few have ever heard of, working on patents that sound more like science fiction than engineering reality. Think about the convergence of new materials science, with advanced patterning techniques that don't rely on light at all. Think about novel chemical vapor deposition methods and multi-patterning that push the limits of physics. There have been unusual partnerships too, a silent convergence of material scientists, AI researchers, and quantum physicists. This isn't a simple engineering problem, it's a foundational rethinking of how we build the smallest components on Earth. We've seen hints of interpreted leaks, small snippets of information that, when pieced together, paint a stunning picture. These projects aren't about playing catch-up, they're about leapfrogging the current system entirely. They're building a new path to the future. A path that doesn't require a single US tool. The hidden AI projects of 2025 are not always what they appear. The real breakthroughs are often the quietest ones. The speed of this is what's truly terrifying. In the past, a new technology node, like going from 10nm to 7nm, would take years of research and development. Product cycles were predictable, almost glacial, but that's the old model. We are now in a new era defined by autonomous learning, where AIs are training themselves to solve engineering problems in a matter of months. This is no longer a human-paced race. Imagine an AI being fed thousands of design parameters, simulating millions of material combinations, and discovering a solution for patterning a chip that no human engineer would ever have considered. That's what's happening in these closed labs. We've seen reports of innovation leaps that used to take 3 years now being accomplished in 6 to 12 months. This is the acceleration effect, and it completely breaks all of our old assumptions about how long it takes to achieve a technological milestone. If we've gone from a theoretical breakthrough to a working prototype in 12 months, where will we be in 12 more? The timeline is no longer a straight line, it's a hockey stick curve. The future of robotics and machine learning is not a gradual ascent, it's a sudden, exponential leap. And the world is completely unprepared for it. The storm is gathering, and its first strike will be felt in the global semiconductor market. We've been tracking vague but vivid hints about a specific event, a massive, almost unprecedented shift in the supply chain. We're talking about a technology function no other system has yet. Imagine a chip so small, so energy efficient, that it can be integrated into anything smart dust, autonomous swarms, or decentralized AI infrastructure. The dual framing here is crucial. The optimistic view is that this could lead to unprecedented leaps in medicine, renewable energy, and scientific discovery. An AI-powered society with limitless computing power could solve the world's biggest problems. But the cautionary view is that the nation that controls this technology, the one that has achieved it in isolation, could gain an insurmountable strategic advantage. We are on the brink of a new era of automation in global industries, where a new kind of power could control our infrastructure. This robotic workforce of 2025 might not be driven by Western technology, but by something else entirely. Something new, something different. Something you are about to learn the name of. For months, we've been tracking the whispers, the patents, and the interpreted leaks. The project, and its codename, has finally been revealed. SMIC's Project Shanghai. It's not a single machine, but an entirely new manufacturing ecosystem. The technology at its core is a breakthrough in self-aligned quad patterning and advanced laser annealing, a method that uses precise guided molecular etching rather than lithographic light. It's a fundamental break from the Western model. It can achieve sub-1 nanometer feature sizes without a single EUV machine. This isn't just about building chips, it's about changing the very rules of the game. The SMIC 1 nanometer chip is not a theory. Sources confirm that prototypes are already being tested. Who's creating it? A consortium of state-backed labs and private companies, all with one goal: technological autonomy. What can it do? Its raw processing power and thermal efficiency are rumored to be off the charts. It can power decentralized neural networks, enabling true AGI without the massive data centers we currently need. How does it change human life? Directly. This technology can put unprecedented power in the hands of one nation. It could lead to breakthroughs in every field, from personalized medicine to clean energy. But it could also lead to a global system where one power has an unassailable lead in AI control of infrastructure, military robotics, and data surveillance. It's a double-edged sword, and its edge is sharper than anything we've seen before. So, what happens now? The world is about to find out that the technological playing field they thought was stable is actually a house of cards. The era of Western dominance in semiconductor manufacturing may be coming to an end. This isn't just a business story. It's a story about power, about ethics, and about the future of humanity itself. Should this technology be shared? Should it be controlled? Should we be worried about the ethical implications of a nation-state having this level of technological superiority built in isolation without any international oversight? Now that you know the truth, you are part of the few who see what's coming. Now that you know, it's your turn to weigh in. Is this humanity's next great leap, or our biggest risk yet? Should we embrace this kind of unilateral breakthrough, or should the world find a way to stop it before it launches? Let me know your thoughts in the comments below. This isn't just about tech. It's about who controls tomorrow. Thanks for watching. This is Revo Now, decoding tomorrow's hidden tech landscape today.